My name is Yu Zhang, Associate Professor at the Biomaterials Department, NYU College of Dentistry. I have always been fascinated by materials science. Its impact on human civilization is enormous. So we're trying to create new structures, new materials which never existed before. Our approach is using a glass infiltration method. So we infiltrate various glass compositions into strong ceramic components such as zirconia and alumina. And in this way now, on the surface of the material, you can have aesthetics, you have bioactivities. In some cases, you can even have antimicrobial properties and better integration with bone, better integration with soft tissue. But on the interior now, you have strong materials, metals and ceramics, give you the structural stability. But you also want a good fatigue life. So we do this fatigue testing using a mouse chewing simulator, see how well they hold up. And then we're going to harvest the sample and looking at the damages sustained from this kind of fatigue testing. The material we made actually is much better resistance to the fatigue damage than most commercial materials. I think that's what makes the material very attractive and have excellent potential. It can be stronger than teeth, that's for sure. But I think the impact is much broader. It can be used in a lot of engineering applications where material is exposed to very harsh environment, very demanding environment, this kind of applications. We have been working on this project for over 10 years, attracting federal grants like NSF, NIH grants, and totaling over $10 million. I think the most important thing is NYU Dentistry has a fantastic research environment, and it provides us with a unique opportunity to directly interacting with clinicians. This way, we can effectively identify clinical problems and so tackle the problems head on. And we also integrate this kind of research activities into teaching to educate next generation scientists and dentists. This kind of training opens up a lot of opportunities for our students. The next step, I think we will continue with this kind of nanostructural design, perhaps combine the both to make it a gradient structure with nanocrystallines. And in this way that we can come up with those new biomedical prostheses and implant devices that we never can anticipate before.